video, we are going to talk about the physical and chemical properties of matter. What is matter? Matter is anything that has mass and takes up space. So what exactly are some examples? Your binder, your desk, water, the air we breathe, your phone, and even us. Look around you. Everything you see in front of you, and even the things you can't see, are all considered matter. How can we describe matter? We can divide it into two types of property, physical and chemical. The physical properties describe the physical characteristics of the substance, the things that we can use our five senses to describe. So the way things touch, the way they feel, the way they taste, the way they look, the way they sound. So some examples would be hardness, texture, luster, odor, sound, the temperature. Or we can actually get into numerical descriptions, melting point, freezing point, boiling point, and actually, as I mentioned before, the temperature, that would be under numerical as well. The chemical properties describe how the substance reacts with other substances. So, for example, what does it do when it's mixed with water? Is it flammable or is it non-flammable? What happens when it mixes with water? Does it rust? Does it react with water? Believe it or not, there are some chemicals out there that react in a negative way with water. Now, the one thing on that chart that I don't agree with is it talks about dissolving being a chemical property. It actually should be under the physical property side, and we will talk about that later with something called solubility. And another example of chemical property is what happens when it mixes with an acid. Does it become corrosive? Physical properties. We're going to focus primarily on physical properties. The definition of physical properties are any property of matter that can be observed without changing the identity of that matter. So in other words, we haven't created anything new. It's still the same substance. We are just describing it. We are going to use our senses to describe these objects. So let's think of how we describe a person. If you're trying to describe, maybe me, for example, you might say, my teacher is short. Yes, I know I am. She has blue eyes. She has long red hair. Those are all physical properties of me or of matter. Here's some examples of physical properties: density, color, odor, taste, hardness, melting point, and boiling point. And here's a few more. We will get into each of these in more detail. Let's start with the states of matter. Now, you've known probably since kindergarten what the three states of matter are: solid, liquid, and gas. It has to do with how the atoms inside of that substances react. Are they close to one another or are they far apart? So if you look at a solid, solids are something that are rigid. They have a definite shape, or as the chart says, a fixed shape. It also has a fixed volume. So no matter where you put the solid, whether you place it on the table, on the floor, it will stay the same shape. So think of your pen. If your pen falls on the floor, it's still a pen. If I put the pen on your desk, it's still a pen. Liquids are not rigid. They will take on the shape of the container. So they don't have a fixed shape. However, they do have a fixed volume. If I poured 100 milliliters of water into a cup, a drinking cup, you would see where that amount of water came up to. If I took the same amount of water and poured it into a bowl, it might look like there's more water, but it's still 100 milliliters of water because it takes on the shape of the container. The last state of matter is gases. Gases are not rigid. They have no fixed shape and no fixed volume. So when you put gas into an object, for example, think of a balloon, it will take on the shape of a balloon. If we put gas into our lungs, it will take on the shape of our lungs. The gas will spread out to fill up the container. Now look at the pictures of solid, liquid, and gas. If you look in a solid, the atoms are very closely packed together. With a liquid, they're spread out a little bit more. And lastly, in a gas, there is a lot more space in between the atoms in a gas compared to that in a liquid or solid. Color. Color's got to be one of the easiest physical properties that we would use to describe. Pretty simple. Just look at the object. Is it purple? Is it pink? Is it yellow? Is it black? Is it blue? Is it green? Etc. Texture describes how something feels. So we're going to use our fingers and we are going to touch the surface. We might say things like it's smooth, it's rough, it's gritty, or it's fine. So if you look at the pictures, there's a picture of sandpaper. Now we know sandpaper comes in different grittiness. So it might be coarse sandpaper, but it might also be fine sandpaper. Ice cubes would feel smooth. Now, don't get this confused with the temperature. Yes, it feels cold, but we are describing the surface, how the surface feels if we rub our hands along it. And the other example is sugar. Sugar or salt, both could be described as fine. The items are very, very tiny. Taste. We use our taste buds to describe the taste of something. Is it sweet, like candy? Is it sour, like a lemon? Is it salty, like the salt, or think of chips? Or is it bitter, like baking powder? Odor. How something smells. It's kind of hard to describe odor because we want to be scientific. We don't want to say things like gross or nasty, even though that's how we sometimes feel. So we're going to say things like sharp. Think of vinegar. Vinegar has a very sharp odor, or you might say very strong odor. Think of a skunk smell. That could be a very strong smell. If it has no smell, like your paper, for example, we would say it's odorless. Luster. Luster describes how light reflects off of the object. So the two pictures there, we have a new clean car and we have a not so clean car. So the clean car would be described as shiny. Look at how well the light reflects off of that car. The muddy truck would be described as dull. There's not light being bounced off of that car. Clarity is the ability to see through something or for the light to pass through. Clear, cloudy, and opaque are the words that we are going to use to describe clarity. Water. Water, we can see through it. It's clear. A window is clear. Cloudy, you could think of as a bathroom window or maybe a frosted shower door where you can kind of see through, but you don't really see the detail on the other side of the glass. Opaque, you cannot see through it at all. So there's definitely no light being passed through a brick wall, for example, or a blackboard. Hardness. Hardness describes how easy it is to scratch a solid. And everything always gets compared to diamond. We know that diamond is the hardest surface that we have. So we are going to use words like hard or soft. And there is something called a Mohs hardness scale, which would give you examples in terms of what is not quite as hard as a diamond. So something that's very easy to scratch could, say, be a piece of chalk or your fingernail. As it starts to become harder, it's going to be more difficult to scratch. Malleability. How easy is it to bend that solid or to hammer it out into thin sheets? So think of gold. If we were to take metal and we were to pound it and pound it, now this is going to take a little bit of effort, but we could eventually pound metal into a sheet. If something is easily bendable or easily hammered, we say it's malleable. If you can't hammer it into a thin sheet, then it is non-malleable. Ductility. Ductility is how easy it is to be able to pull that solid out into a thin wire. The example I love to give, and I couldn't find a picture of, think of chewing bubble gum. You take the gum, you start chewing it, then you start to pull that gum out of your mouth, which the teachers are always saying, I don't want to see your gum. But if you're pulling on your gum, you are showing ductility. Crystal form. The crystal form is what we use to describe when something has a regular pattern, a three-dimensional pattern. So if you think of salt, Now, you probably really haven't thought that salt is a cube, but if you look at it under a microscope, which the picture on the right side of the screen demonstrates, salt and sugar is actually tiny little cubes. So we would describe it as a cube when we're talking about its crystal form. Flour that we use to make cookies with does not have a definite three-dimensional pattern, so we would describe it as a powder. Solubility is how easy it is for matter to dissolve in water. So if you think of sugar, when we pour sugar into our coffee, it doesn't just sit there or it doesn't just float around or sink to the bottom. It dissolves. The sugar is still there in the liquid coffee. We can't see it because it has dissolved. When we say something can dissolve, we call it soluble. If it does not dissolve, like pepper, black pepper does not dissolve in water. If you don't believe me, give it a try. We would call it insoluble. Now, the different parts of a solution, which is what we will make when something dissolves, we have something called a solute, which is the stuff dissolving. The solvent causes the dissolving, which is usually water, and we end up with a solution. Viscosity is the ability to pour or flow. So we have to talk about a liquid when we talk about viscosity. The more viscous a liquid is, the less easy it will pour or flow. So think of honey or think of molasses. That's why they always use the saying, you're slow as molasses. It's pouring very slowly. So we would say it is more viscous. If something is less viscous, it's going to pour very easily, like water. This diagram just shows different liquids. So we start off with water, then it goes to milk, oil, think of vegetable or any type of cooking oil, a light syrup, like maybe corn syrup. Then as we get a little heavier syrup, like molasses or honey, and then lastly, chocolate syrup. When you look at the liquids that are coming out of the spoons, some are pouring just a little, some are taking a lot longer to pour. They're sticky, they're sticking together, so they are more viscous. Density is the amount of matter in a certain amount of space. It basically comes down to weight. I guess that could be an everyday way of describing it. If something is more dense, it's going to be heavy. If it's less dense, it's going to be less heavy, so it will float on top. So think of oil and water. Water is more dense than oil. That's why the oil floats on top. If you look at that picture on the side, this is what we call a density tower. It would not matter what order we poured those liquids into the container. This is how they would all eventually end up. Now, they even put some things in there like a ping pong ball. And if you look kind of down in the middle, there's a bead and a soda cap and a cherry tomato. So what we can do is we can put the liquids in and then put solid objects in to show which objects are more dense and which ones are less dense. This shows what really is behind the science part of density. Density has to deal with how tightly packed matter is. So it's the amount of mass in any given space. So remember I said it has to do with weight? So with a gas, it's less dense. As you go towards a solid, look at how those little smiley face circles are jam-packed in there. There's a lot more in there. They're more dense. So a solid tends to be more dense or heavier than a liquid and a gas. Melting and boiling point. These are the temperature at which matter will change state. So if we talk about melting point, think of an ice cube melting, if you sit it on the kitchen counter. It is the temperature at which a solid will change to a liquid. Boiling point is the temperature at which a liquid will change to a gas. So think of when you're making water for tea. You put liquid water into your tea kettle, you add heat, eventually steam will start to come out as the water boils. Freezing point is another temperature we can look at, and it's a temperature at which a liquid changes to a solid. So again, let's go back to liquid water. We fill up our ice cube trays, put it in the freezer. A few hours we come back, that liquid has now turned to a solid. So why do we even use physical properties? We use them to separate substances. If we have two substances and we're not quite sure what they are, and we're trying to identify them, we could use the physical properties. So if I had solids and liquids, that would be one way to separate them. I could put all of the solids together, and then I could put all of the liquids together. If I now am looking at maybe just solids and I have two white powders, I could use those physical properties to identify what substance I have. Let's think of sugar and flour. If we have the two white powders, white solids, what's the difference? Well, one has a powder crystal form. One has a cube crystal form. So just looking at that physical property alone could help me distinguish between the two. Again, that's going in now to the third point, to distinguish between substances. And the fourth point, to predict the usefulness of a new substance. So if I've discovered something new and I'm not quite sure what it is, I might be able to guess or predict at what could happen if I maybe mix it with water, or if I mix it with another substance. Maybe I could guess the density of it. So by using physical properties, we are able to identify substances and make sure we're not using the wrong thing.